Hello everyone. Myself Kausik Beda, Assistant Professor of Civil Engineering Department, Haldia Institute of Technology. Today I am going to lecture on fluid dynamics. About the fluid dynamics, what we have to know the different type of energy, just like kinetic energy, potential energy, pressure energy, internal energy. So, what is kinetic energy? Energy due to motion of a body is called kinetic energy. So, a body of a mass m moving with a velocity v. So, we can say the half mv square. So, potential energy is what? Potential energy is due to the elevation of a body above an arbitrary datum is called potential energy. So we can say the potential energy is PE equals to mgz, or we can say H. H if we consider the elevation of a body from arbitrary datum, or Z is elevation of a body from arbitrary datum. Next is potential pressure energy. So pressure energy is due to the pressure above the datum. Most usually pressure above the atmospheric pressure. So PRE, we can say that is equals to gamma into H. H is a height from the above the atmospheric pressure height. So internal energy, it is the energy that is associated with the molecule or internal state of matter. It may be stored in many forms including thermal, nuclear, chemical and electrostatic. So different heads are important for this module. So what are the different heads? Kinetic head, potential head, pressure head. So total head. So but you have to know what is head. We can say that the energy per unit weight is called head. So kinetic is what? Kinetic energy per unit weight. So kinetic head, it's called kinetic energy Ke by weight. We can say half mv square by mg. It's become v square by 2g. Potential energy. Potential head is potential energy per unit weight. So we can say potential head equals to Pe by weight. So mgz by mg. We can say that z. Pressure head is pressure energy per unit weight. So we can say the P by gamma. Total head means kinetic head plus potential head plus pressure head is called total head. We can say V square by 2G plus Z plus P by gamma is called total head. Summation is called total head. So in this module, so Bernoulli's equation is very important and it is most famous equation in fluid dynamics. So it states that the sum of kinetic potential and pressure heads of a fluid particle is constant along a streamline during a steady flow when the compressibility and frictional effects are negligible. That means frictional effect, different type of frictional effect. It may be the minor, it may be the major frictional loss. We are negligible. We can say that this is the negligible. So that means for an ideal fluid, the total head of a fluid particle remains constant during a steady incompressible flow, or total head along a streamline is constant during steady flow when compressibility and frictional effect are negligible. So total head equals to Z by Z plus P by gamma plus V square by 2g is constant as per Bernoulli's equation. So if we consider a pipe, inlet is 1 and outlet is 2. So in this pipe, inlet pressure head is P1 by gamma plus velocity head is V1 square by 2g, and the potential head is Z1. And as similar, the potential head is for outlet is Z2, pressure head is P2 by gamma, and the velocity head is V square by 2g, V2 square by 2g. So it will become P1 by gamma plus V1 square by 2g plus Z1 equals to Z2 plus P2 by gamma plus V2 square by Z equals to constant. That means the total head is H1 at inlet and total head is H2 at outlet is equal as per Bernoulli's equation. So derivation of the Bernoulli, how it's derived. So there is some assumption. What are the assumptions? Fluid is ideal and incompressible. Ideal fluid, there is no viscosity, and the incompressible means there is no volume changes due to the pressure, and fluid is steady. That means the along the streamline it is steady, and it is fluid is also along streamline. Velocity is uniform across the section and is equal to the mean velocity, only gravity and the pressure forces are acting. So we consider, as per Newton's second law, we know that the force equals to mass into acceleration. Okay, so we can say the acceleration is dv by dt. That means the differentiate of velocity. So we can write the ds by uh, ds by dt by d into dv by ds. So we can say ds by dt is v. So we can say as acceleration is v into dv by ds. Similarly, total forces is equals to P into dA minus P plus dP into dA. In this force acting on the particle streamline in shown in slides, we can say that the along the streamline S and steady flow along that is marking on arrow, and we take a small pipe which is length is ds and the inlet pressure is P into dA and the outlet pressure is P plus dP into dA, and the weight is downward and there is theta angle, gravitational is g, and there is some triangle, and including the theta equals to sine theta equals to g dz by ds. So w equals to weight of a fluid. It is, we can say the mg we can say rho into dA into ds into g, and w sine theta, this is a component acting along the x direction, dA is the area flow, and ds is a length between the section along the pipe. So now we can say force acting the s direction is become P into dA minus P plus dA dP into dA minus W sine theta. So in this equation 3 and the equation 1, if we consider, so it become m into a, that means the force equals to mass into acceleration. So this force will become mass into acceleration. So P into dA minus P plus dP into dA minus W sine theta equals to m into v dv by ds. So it's become minus dp dA minus rho g dA ds dz d by ds equals to rho into dA ds v into dv by ds. Cancellation dA and simplifying minus dp into rho g dz equals to rho v dv. So note that v dv equals to half dv square. So we become minus dp into rho g dz equals to rho into half dv square. So dividing equation 5 by rho, so it's become dp by rho plus g into dz plus half dv square equals to 0. Integrating these things, it's become constant, assuming incompressible steady flow. So p by rho plus g into z plus half v square equals to constant. Dividing each equation by g, p by rho g plus z plus v square by 2g equals to constant. So finally it's become total head h1 z1 by p1 by gamma plus v1 square by 2g equals to total head 2 rho g z2 plus p2 by gamma plus v2 square by 2g. Its equation derivation is become this equation. So now energy line and hydraulic grid line. So energy line is total head, we know the pressure head, velocity head, and the potential head. So it's become P plus multiplying with the gamma, it become P plus rho g z plus rho into v square by 2g equals to constant. So here P equals to static pressure, dynamic pressure become rho v square by 2, hydrostatic pressure is become rho g z, and stagnation pressure means static pressure plus dynamic pressure is called stagnation pressure, P stag. So P stag become equals to static pressure is P and dynamic pressure is rho v square by 2. It's become stagnation pressure. So now here the energy line and hydraulic grid line measurements of head with the different device we use, piezometer, pitot tube, the different tool, or you can say the different measurement we used. So here the piezometer is measure with, this is in these slides we can see that the piezometer is here, that some tube, a vertical tube, and through this there is some we can say the measurements scale. So through this we can say the piezometer head pressure head P by gamma we can measure. So total upper is EGL, energy grade line, and the lower dotted line is HGL. This is hydraulic grade line. So P dot T, we can measure the pressure and velocity head. So in this pressure velocity heads from the reference line, we can say P by gamma plus V square by 2G. So this is, we can say, as reference line. So these are the are from this arbitrary line, AGL and EGL we can measure. So this is the derivation how to EGL and the EGL will become in this diagram. So with this refer with the previous discussion, we can measure like this way. So we can say that the external work done plus heat transfer is change of energy. So it's become for steady flow, the external work done on any section, any system plus thermal energy transferred into or out of system is equal to the change of energy system. And the flow work is when the pressure forces acting on the boundaries move. In present case, P1 A1 and P2 A2, the end section move through del S1, del S2, external work is done. It's referred as flow work. Shaft work, the weight energy by time weight into time, it's shaft work. And the heat transferred from external sources into the fluid system over the time interval, del T is become the heat transfer slow. It's shown in slides. And change is energy. So these are the equation of change is energy. And finally, energy equation for steady flow and any fluid become P1 by gamma 1 minus Z1 into alpha B1 square by 2G plus I1 plus HM plus QH, P2 by gamma 2 plus Z2 plus alpha into P2 square by 2G plus I2. So it's basically the flow work and shaft work plus heat transfer. Its difference, it's become the, this is the general form of energy equation which is applied to liquid, gases, vapor, or ideal fluid, as well as the real fluids with friction, both incompressible and compressible. Only restriction is that the steady flow. It's steady flow. So for the incompressible fluid, gamma equals to same. The substituting this value incompressible for incompressible fluids, it's become this equation, and the HL become I2 minus I1 minus QH. This is the head loss, and HM is removed, added by the mechanics, and this equation 11 is become. In the absence of a machine pipe fitting, etc., it can be written as like this. H is a HL, this is the pipe friction or only caused by the wall or pipe friction. HL become the HF, and HF is a head loss due to the friction. So now power. Power is what rate of work done is termed as power. So power, it's become energy per time. So energy plus weight by weight plus time. So we can say the H into gamma into Q. Okay, so it's become H is total weight, the total energy by weight, and gamma Q is the weight of flow rate. Then the equation become H into gamma into Q. So Q gamma H is power. Okay, so in SI unit is kilowatts, in BG unit is horsepower. So now the momentum and forces in fluid kinematics, this is the different thing. So we can say the summation of it's become the Newton's second law. If summation of F equals to laws of motion, m into a, so we can say d into m vs by dt. So it's become the momentum forces per fluid is become summation of this, and if summation of F means some external forces of a body of a fluid system, mv equals to momentum of fluid direction. So summation of F into dt equals to become d into mvs. It's termed as impulse momentum principle. So this is the impact of jet of a plane. This is the plane area. So this is impact. This is the v1 is tangential and theta is become, and the vector dimension. So it's v1 cos theta, v1 sin theta, and v1 is become. So it's the jet impact on a jet on a plane. So impact on a jet on a plane, if the direction is changing 45-degree angle, so the velocity direction will be changes. Thanking you. Thank you so much everyone for listening.